GameSci.com.
Let's look now at the else if statement, which really isn't a new statement. What I'm going to do is immediately follow an else statement with another if. I'm going to sort of chain or domino these things together so that several if else statements are run back to back to back. The best way to show it to you is to trace it. This once again is a specialized form of the if else statement where I'm combining several of them into a block of code. Let's start with a damage variable that contains 12 and a health variable that contains 100 and trace what this code does with those variable values. With a damage equal to 12, 12 greater than 10 is very much a true statement. As a true statement, in the if portion, we expect this code to select the if code to execute. So we'll do a health equals a health minus 8 because we received high damage. We're going to subtract a lot from the health point. And our 100 in the health variable just shrunk to 92 in the health variable. Take a lot of damage in a video game, you expect your health variable to go down. And that's what it did. Now, what happens after we execute an if portion of an if else statement? It skips the else. Now what you have to understand that this if is attached to that else. So if this if is true, we have to skip this else. What you may not see is that all of this code is part of that else. Remember, if there's one and only one statement after the else, you don't need curly braces. So rather than putting a curly brace here, I immediately put a single if else statement. And what I'm going to do is skip this entire if else statement. So everything I have outlined here will be skipped in this else if statement. I'll follow this path, I'll skip the else, and basically the only line of code that executed here was the health equals health minus 8. That's what an else if statement does. An if statement is a one-way decision. An if else statement is a two-way decision. And the way I've designed this is I've designed an else if statement to be a four-way decision. I'm setting up one of four paths. 1, 2, 3, or 4 paths. And this code will only ever execute one of those 4 paths. So let's change the damage variable to 5 and rerun this same code. You can see I've updated the value of the damage variable to 5, so I have a completely different input to this else if statement of 5 in the damage variable. Health, I've retained the 92 in it. Let's see how it runs now. Damage contains a 5, so damage greater than 10 will evaluate as 5 greater than 10, which is very much a false statement. When the if statement is false, what do? We go to the else and follow this line. This if was false, so I'm going to execute this else. Well, what's immediately following that else? Another if statement. And in that other if statement, damage is greater than 6. I'm taking slightly less damage. 5 greater than 6 is still a false statement. Remember, if the if portion is false, I've got to go to its else. And there is an else immediately following this if. Tracing the code again, because 5 greater than 6 is false, I'll go to the next else statement. This if is attached to that else. If this if is true, I'm going to execute the statement immediately following the if. The statement immediately following the if is damage greater than 3. 5, which is in the damage variable, is greater than 3. That is very much a true statement. As a true statement, we know what it's going to do. It's going to execute the code in the if statement. 5 greater than 3 was true, so I'm going to execute a health equals health minus 2. My 92 just went to 90. You see what this code is doing? If I receive a lot of damage, I'll subtract 8. If I receive a moderate amount of damage, I'll subtract 4. If I receive a smaller amount of damage, I'll subtract 2. What happens after the if is true and we execute the code in the if? Why, we skip the else, of course. This if is attached to that else, so if this is true, I'm going to skip that else and continue on. See it? Pretty straightforward. I'm selecting one of 4 paths. In this particular case, I chose, or the code chose, to select the 3rd option. Whenever I want to write code that chooses between 4, 5, 6, 7 different options, I can use an if-else statement like this, and each if will select one of the different paths, and when it selects the path, it will skip the remaining paths. Set damage equal to 2 and try this again. You can see I've updated the damage variable to 2. My health variable contains 90 again. This looks like code I'm going to run every time I get hit. Every time my player in the video game gets some sort of hit, either a punch or a bullet or some sort of damage, I'm going to run through this health, and depending on what hit me, I'm going to subtract more from my health points. You get shot, you expect to lose more points than if you got punched. And that's what this code is deciding. How big was the damage and what sort of consequences to my player's health points should there be? So 2 seems to be a small amount of damage. Let's see what happens when damage is 2. Damage greater than 10. With 2 in the damage variable, 2 greater than 10 is very much a false statement. As a false statement, it will skip the if block and go straight to the else. And here it is. It went straight to the else. This else is attached to that if. 2 greater than 6 evaluates again to a false statement. Damage is 2. 2 greater than 6 is false. When the if is false, I jump to the else. This else is attached to that if, so I'll jump to this statement immediately following the else. Damage greater than 3, 2 greater than 3 is still a false statement. As a false statement, I will jump to the else. I jump to the else that is attached to this if. See that if? The closest else is that one. I'm jumping to its else, and I will jump to this else and execute a health equals health minus 1. You can see my 90 changed to 89. If all 3 if statements were false, that's when this last else executes. This last else is sort of a catch-all. If all 3 of these ifs are false, by default, I will only subtract 1 health point. Remember, this is the code that executes when my video game character takes some damage. So I know when this code executes, something happened. If I get a large amount of damage, I subtract a larger amount from health. But if I get a small amount of damage, I only subtract a small amount from the health variable. There you have it. When I'm done with the else portion of the code, of course it will leave this code, and we're done with that code. That is the if-else statement. When you have a one-way decision, you use a simple if. You have 2 different choices of code to execute, you use an if-else. When you need to choose between 3, 4, 5, or more paths, select one of these different options. Use the else-if statement. What we're doing is we're chaining another if-else to the end of if-else. So this one is changed to the initial if-else, and this one is changed onto the second if-else, and this final else is sort of our catch-all. It executes when none of these options are true. There is a competitor to the if-else statement called the switch case statement, sometimes just called the switch statement. Once again, like the else if, the switch case statement chooses between one of multiple paths. If I only have to choose between 2 options, I use a simple if else. But what if I had 3, 4, 8, 20 different options and I wanted to select one of many different options? That's when you use an else if, or you use this newer switch case version. We'll look at how it works by tracing the code. Start with weapon and a value of 1. What will this code do if my weapon variable has the value of 1 in it? With the value of 1 in the weapon variable, I'm going to switch on the weapon variable. When I switch on the weapon variable, I will compare the value in weapon to one of these many different cases. And really what I'm asking is, does weapon match case 1? Does weapon match case 2? Does weapon match case 3? When I get a match, I will select the code underneath the case to execute. So with a weapon value of 1 and tracing this code, case 1 matches weapon. Weapon has the value of 1, so weapon matches case 1. When we have a match between the weapon and the case, I will select that code to execute. Since we had a match, I will go inside the case 1 code and execute weapon name equals shotgun. You can see I've stored shotgun in my variable weapon name. That's it. When weapon matches the case, you execute that code. I will select one of 1, 2, 3, 4, 5 different paths. Just like the else if, what I'm doing is choosing one of these 5 different sets of code to execute. And since weapon matched case 1, this executes. After the weapon name equals shotgun, it will hit what's called a break statement. And that literally says break me out of the case. I found my match. I set my weapon name. I want to break out of the code. And what the break statement does is it follows this path outside of the switch. It literally means break out of the switch, and the code after the switch case statement will execute. See what we're doing here? We're selecting one of these 5 different paths to execute. Set weapon equal to 3 this time and make it follow a different path. Switch on the weapon variable, so what I'm really switching on is the value 3 because weapon contains a 3. What happens when we have a weapon value of 3? Well, first of all, case 1 no longer matches. Weapon, which is 3, does not match case 1. So this is a false statement. When it's a false statement, as you would expect, it's going to skip to the next case. So because case 1 did not match weapon, we'll go check case 2. When we check case 2, weapon, which contains a 3, matching case 2 is a false statement. It is not a match. Weapon does not match case 2. So as you would expect, we're going to skip case 2 and go to the next case. The next case happens to be case 3. The value in weapon does match 3. Weapon contains a 3. Case 3, it's a match. Since this is a true statement, it's going to execute the code in case 3. So weapon name equals Uzi executes. You can see my weapon name variable changed to Uzi. After I set the weapon name to Uzi, I'll fall down to the break statement. I'll execute the next code in the case statement. The break statement does, as we've already explained, break you out of the switch. I selected case 3 to execute. I will break and get out of the switch and continue on with the program after the switch case statement. See that curly brace down there? That is the end of the switch. The break will take you to the line of code after the switch, after that closed curly brace. Let's start with a weapon equal 99 and see what happens. Weapon equal 99 is none of these cases. So let's see what happens. I have the 99 in the variable weapon. I still have my Uzi from the last time this executed in weapon name. Weapon value is 99. So what I'm really switching on is 99. Compare 99 to all the different cases. Does 99 match case 1? Absolutely not. That is false. So I'll fall down to the next case and check case 2. Does 99 in weapon match case 2? That's a false statement. Once again, I'll fall down to case 3. Does the 99 in weapon match case 3? Does the 99 in weapon match case 3? That is very much a false statement. So I fall down and check case 4. Does the 99 match case 4? Absolutely not. That is false. So what's going to happen here when I have a value of 99 in weapon is it's going to hit what's called the default case. The default case matches everything. The default case says if none of these match, execute the default. It's kind of like that final else in the else if statement. It matches everything. If my weapon number does not match 1, 2, 3, or 4, it will execute the default. When it executes the default, weapon names will go to fist. You can see there's my new value and weapon name. And of course, when it finishes executing that case, it continues on with the program and executes the code after the switch case. There you have it, the switch case, a direct competitor to the else if. I tend to go with else if I have 4 or 5 cases, but if I ever have a piece of code that has to choose between one of 10 options or 20 options, the switch case is a little nicer than the else if statement. I think that's my personal opinion. Wow, these are all selection or control statements. Is it clear? This switch case statement is selecting which code to execute. It's choosing or controlling the path the program takes. If my weapon is set to 2, it would take this path and then the break would take it past. Do you see why they're called selection statement? It's pretty clear here. It's selecting which one of these 5 options should this code execute at this point in time. And it's all based on the value of weapon, the variable used in the switch. Okay, let's look at something called the AND logical operators. Logical operators produce true-false values. Logical operators can be used in conjunction with relational operators. Remember what relational operators do. They compare 2 numbers and they return true-false. They provide an essential ingredient for selection statements, things like if else, and else if statements, to determine which code executes. Well, what logical operators do is let us build more complex Boolean or conditions to decide how to execute which code in the if statement. This is the AND logical operator. When I have a couple of conditions, condition is a true-false value. Condition and Boolean mean the same thing. A condition is anything with a true-false value. A Boolean is anything with a true-false value. So what an AND logical operator does is let me string together or build more complex if statements to decide which code executes. So looking at the AND logical operator, let's see how it works by tracing the code. You can see I've built a much more complex if statement here by tying together 2 relational operators with an AND. Let's see how it works. Let's put the value of M in the rating variable and the value of 18 in the age variable. When I evaluate rating equal M, the equality operator here says M matches M. This is very much a true statement. Then I'll go over and evaluate the age greater than or equal to 17. Age contains an 18, so this is 18 greater than or equal to 17. That is also a true statement. Turns out both sides of the AND are true. Well, that's interesting. The way I remember the AND logical operator is it's all true to be true. You can see here in the truth table, when both of my inputs to the AND logical operator are true, when I AND them together, I get a result of true. So when both inputs are true, I expect the AND to return a true value. And sure enough, you AND true together and you get a result of true. Focus on this line of the truth table. If both my inputs are true, then the result of the AND is a true logical operator. This here is called a truth table. It goes through all possible inputs of true and false for the AND logical operator and tells you what the output should be for those 2 inputs. Remember, all true to be true, the only time the AND produces a true result is when all the inputs are true. Let's trace this again with different inputs for rating and age. Set the rating for T for teen and the age to 17 and see what happens with this if statement and how it evaluates. First of all, our rating is T, so T equal to M is a false statement. After we evaluate that side, we'll go over here. Our age is 17. Age greater than or equal to 17 is a true statement. 17 greater than or equal to 17 is a true statement. So my input to the AND is false and true. So when I AND those 2 things together, what happens? I get a result of false. Look at this line of the truth table. False for the left operand, true for the right operand. All true to be true means this has to be a false. So we're going to output a false on the AND. So this if portion will not execute. It's going to skip past the if block on the code. So there you have it. That's the AND logical operator, and this is the AND truth table. The way I always remember the AND truth table is all true to be true. The only way an AND will ever be true is if all its inputs are true, and that's what this line is showing you. If my first or left operand is true, but my right operand is false, then the AND will output a false. If my left operand is false, but my right operand is true, then the AND will output a false. And of course, if both inputs are false, then that result of the AND will be a false. AND simply means what the English language word AND means. AND means both have to be true. If you want to go to college at Stanford University, one of the best computer science schools in the country, you have to have good grades and high SAT scores. And the only way you're going to get in if both those things are true. So AND means exactly like the English language word AND means. You've got to have both inputs to be true for the result to be true. All true to be true. Next up, the OR logical operator. The OR logical operator means exactly like the English word OR means. OR means only one has to be true. The only way an OR is false if all the inputs are false. So let's trace the code again and see how the OR logical operator works. Once again, OR is going to be used between two relational operators, or two true-false values, to determine whether overall the if statement is true or false. So I've set up a couple of variables here. Paid user is set to true. Credits is set to 37. And let's run these values through our more complex if statement. Paid user is a Boolean variable. Whatever's in the Boolean variable true will be the result of this Boolean variable paid user. Credits greater than 100, 37 greater than 100 is a false statement, so the other side of the OR is false. However, OR is not so picky. OR only cares if one of them's true. Focus on this line of the truth table. If my left operand is true and my right operand is false, my output is true. So I have a feeling this OR operator is going to return a true. OR only requires one side of the OR to be true. Since the left operand is true, the result of the OR is true. Overall, this if statement is true, and it's going to execute the code in the if block. Let's try it again with different values in the variables. You can see paid user now contains a false. You can see credits contains a 91. A different input. I expect this code to evaluate differently. First of all, the Boolean variable paid user is returning a false. That's not going to kill us. We still have the other side of the operand. Credits greater than 100. 91 greater than 100, however, is a false statement. Now we see that both sides of the OR are false. What do we expect to happen? If you OR together two falses, look at this line of the truth table. False, false produces a false. That's my memory trick for remembering the OR logical operator. All false to be false. The only time an OR is going to be false is when both inputs are false. If any input is true, then the OR will produce a true. But if all the inputs are false, the OR will produce a false. This OR rightly returns a false. Both sides of the OR logical operator were false. So that is the OR logical operator. It does exactly what the English language word OR means. One input has to be true. If your mom says she'll buy you a video game if you clean your room or wash the car, she only expects you to do one. Clean your room, doesn't matter whether you wash the car or not, mom's buying you that new video game.